In this video, we're going to take a look at the similarity in right triangles. And we're going to start with this triangle right here, where we have side A, side B, and side C. Now what I want to be able to do is I want to be able to drop a right angle in altitude straight down to line C. This is going to let me see that my altitude or height H of this whole triangle. Now this is a right angle here. And I'm going to call this segment X and this segment Y. So what I've effectively created is three triangles. The large triangle, the middle or the medium-sized triangle, and the small-sized triangle. So just to label them in this way, I have the large triangle 1, a medium-sized 2, and a small-sized 3. So how can we set up to understand some of our proportions? Let's start by understanding that the large triangle ABC here, what I've done for myself is I've made a tool, and my tool is a trace. So what I have is the triangle that we have here, ABC, where C is the hypotenuse. When I turn this all the way, A is on bottom and B is here. And I'm just turning it and lining it up in this way. So after I have it turned and lined up in that way, what is nice is if I can figure out what is the medium triangle. Well, I know the medium triangle is a right angle. Across from that right angle is B. So if across from that right angle is B, what I have to think about is this angle here. This angle, where the B and the Y are between each other, I can mark on my trace. So what I'm going to try and figure out is how does the B line up with that right angle? And the B goes to that C side. So now that I have my angle B marked, all I'm going to do is I'm going to turn my right angle here to line up with the original right angle. And when I do that, I can get my angle and angle together. Now, it's a little bit hard to come through on the camera, but what I have is Y is where the B is. So I'm going to place a Y on that B side. And then across from that would become the H. So this lets me get to my third triangle that has A in the hypotenuse, and if H was the long side of the middle triangle, H becomes the opposite side there, leaving X to be the last side. This is going to allow me to set up proportions from one triangle into the next. This is using angle-angle similarity. That's all I'm trying to do. I'm really running it off of the between B and C angle. And it's all I'm really going after. So by using that, I can set up my triangle proportions. Now, if I wanted to be able to apply and use my triangle proportions, I need to know a thing about the geometric mean. So if I have triangles with some lengths, so I need to be able to use the geometric mean. So using the geometric mean, what I'm going to do is I'm going to try to find the geometric mean between two numbers. Let's say 4 and 25. That means there's something in between 4 and 25 that works for both. So I could set it up so that I have 4 over X. 4 is the short, 25's the long. So X over 25. So I need that number that will work for both. So I'm going to solve it using proportions to say that 100 is equal to X squared, or X is 10. Now we know that the square roots can give us positive or negative numbers, but in this case what we're actually going to think about is that we're measuring length. and length is a positive number. So knowing this geometric mean to get in between what we had on our previous triangles. So if I come back to my previous triangles here, what I have is the side A, side B, side C triangle. It has an altitude of h, and it is split up on the C side to have an x and a y. So what if I wanted to be able to find lengths, specific lengths of sides? Then I would need to know certain proportions. So to shift this paper a little bit, I can see that h, using from the geometric mean, h squared is going to be equal to x times y, or we could just simply say that h is equal to the square root of xy. And I'm trying to skip through proving it all the way through for people, but what we're using is the Pythagorean theorem, that a squared plus b squared equals c squared. This same idea means that a squared is equal to x times c, or we might say that a is equal to the square root of xc. B squared is equal to yc, or we might simply say that b is equal to the square root of yc. So let's use this in order to find missing segments or unknown lengths. So if I have a right triangle and it has an altitude, and I have a couple missing spots, an x, y, and a z, but I have two known lengths, a 1 and a 2. So in order to find x, I'm going to use the geometric mean, and I know that 2 over x is equal to x over 10. So this means that x squared is equal to 20, or x is the square root of 20, which is 2 square root of 5. If I wanted to find y, then 10 over y is equal to y over 12, the 10 plus 2. This means that y squared is equal to 120, or y is equal to the square root of 120, which is 2 radical 30. So I'm able to find my x and my y. No real trouble there. Remember, math rocks with a capital M.